Chapter 2, Lesson 3 of Geometry. We are looking at deductive reasoning, and in this video we want to take a look at the law of syllogism. Another law of deductive reasoning is the law of syllogism, and the law allows you to state a conclusion from two true conditional statements when the conclusion of one is the hypothesis of the other. So basically in mathematical notation it looks like this. If you have a statement that says a conditional, if P then Q, and then you have a second conditional, if Q then R. Notice that the Q's here are the same. So the conclusion of this first one and the hypothesis of the second one are identical. If that's the case, you can then basically, what I kind of say or what I kind of think about it, maybe this has helped you, you can kind of reduce these out, take those away, and what are you left with? If P, then R. So the law of syllogism is kind of like a reducing thing. I kind of like to think of it that way. The only condition is, or the only thing I need to look for then, is the conclusion of one and the hypothesis of the other identical. So that's what we would be looking for. So really quickly then, the law of syllogism requires two conditionals, two true conditionals, so we need to establish that fact first. And the conclusion of one of the conditionals is the same as the hypothesis of another. And if that is the case, we're writing a brand new conditional then is what we're going to do. So we're going to end up with a whole new conditional statement. So it's a little bit different than the law of detachment where we came to a conclusion about something. In this case, we're actually coming up with a new conditional statement. So let's walk through this one example. If a number is prime, then the number does not have repeated factor. That would be a conditional statement. We have another conditional statement that says if a number does not have repeated factors, then the number is not a perfect square. And you'll notice that this conclusion, what follows the word then, the number does not have repeated factors, in this conditional is identical to the hypothesis, a number does not have repeated factor, in this conditional. So because that's the case, the conclusion of this first statement and the hypothesis of this second statement are identical, we can reduce the common statement and leaving us just a new conditional. And what I mean is, if you block out what's the same, okay, this was the same as this, what you're left with, if a number is prime, then the number is not a perfect square. You'll see we're left with this new conditional statement. If a number is prime, then the number is not a perfect square. So that's applying the law of syllogism. So it's kind of like an algebraic thing, at least that helps me think of it. We can cross out or reduce what's in common, and then what we're left with is our new conditional statement. That's applying the law of syllogism. All right, so a couple questions to think through as you're doing this is you first have to ask, is the conclusion of one conditional the same as the hypothesis of the other? An important note here is to notice that it doesn't matter what order they're in. In other words, you're looking for a hypothesis and a conclusion that are the same. It doesn't have to be the first conclusion and the second hypothesis. It doesn't always have to be that way. And usually what happens is most of them are set up that way, but then when we switch it around, we have a tendency to kind of get lost a little bit. But we're simply looking for a conclusion in one and a hypothesis in the other that are the same, and the order does not matter. If it's the case where we can identify that, then we can apply the law of syllogism. If that's not the case, then that law of logic, that law of syllogism cannot be applied. Okay? And if we do apply it, then what we're doing actually is writing a brand new conditional. So let's do a couple of examples. So if an animal is a red wolf, then the animal's scientific name is Canis rufus. If an animal is named Canis rufus, then the animal is endangered. So I'm looking for a hypothesis and a conclusion that are the same. So here's a hypothesis, an animal is a red wolf. I can look at the conclusion here, animals is endangered. Those are not the same. Here, the conclusion, the animal's scientific name is Canis rufus, and here a hypothesis, animal name is Canis rufus, those are the same. So what I can do essentially is to reduce those out. So I can imagine, take this out right here, that conclusion, take that out with this hypothesis, And what are we left with? If an animal is a red wolf, then the animal is endangered. So because the conclusion of number 1 and the hypothesis of number 2 are the same, we can apply the law of syllogism and come up with this brand new conditional statement. All right, let's do another example. If two planes intersect, then the planes intersection forms a line. If two planes are not parallel, then the planes intersect. So here's a hypothesis, two planes intersect. Here's a conclusion, the planes intersect. So I have a hypothesis and a conclusion that are the same. Notice that the order isn't exactly the same as the other one, but the hypothesis and conclusion are the same. So I can imagine ignoring those. Okay, and then we have it then what's left is if two planes are not parallel, then the planes intersection forms a line. So because the conclusion of 2 here and the hypothesis of 1 are the same, we can apply the law of syllogism and come up with a brand new conditional. All right, I think I maybe have one more example, maybe 2. If you read a good book, then you enjoy yourself. If you enjoy yourself, then your time is well spent. So again, here's a hypothesis. If you read a good book, the conclusion, not the same. Here's a conclusion, you enjoy yourself. Here's a hypothesis, those are the same. So we can reduce those out, and then we're left with then, if you read a good book, then your time is well spent, because the conclusion and the hypothesis are the same. Okay, so that's the law of syllogism, and make sure you consider those 2 things. You're looking for the hypothesis and conclusion that are the same, and again, the order doesn't matter, you're just looking for 2 that are the same.